All right, let's go over these. This is the for 8.1, 4 through 7. 4, 5, and 6 are very similar to the problems I did on our first Zoom session this week for week 7. So if you want a refresher, check that out. The Zoom recordings, they're on Canvas for week 7. It's the first Zoom session. Okay, I'm going to do a couple of these and then we'll go from there. Okay, so let's check out number 4. So we want to check out if this is a function, yes or no. So if you remember from my Zoom recording, I had mentioned that this number is your input, this number is your output. In other words, this is your X, this is your Y, okay? And I use the store analogy that says, if this is item 3, this number tells you the price for item 3. So in other words, item 3 costs $2, if that's how you want to think about it. Item 4 costs $2. Item 5 costs $2. Okay? In order for this to be a function, each item should have their own price. Okay? Basically, one item can only have one price. So if you look, does item 3 have one price? Item 3 has a price of $2. So let's check. Is item 3 listed anywhere else? And the answer is no. So item 3 has only one price of $2. So now we go to item 4. Does item 4 have only one price? And the answer is, let's check. So item 4 has a price of $2. Do I have item 4 listed again? And yes, I do. But what you'll notice is it's the same price, which is okay. That means item 4 has one price. It's $2. Okay? So we're good. Item 4 only has one price. It's $2. Now we check item 5. Item 5 has only a price of $2. There's no other item 5 out here. Okay? We already checked this guy. Item 6 has a price of $2. Okay? So if you can imagine what's going on here, which is a perfectly thing to happen at a store, is we have all these different items and they so happen to be the same price. So think of going to a store and you buy a Pepsi, you buy a Coke, you buy a 7-Up. They're all different items, but they should have the same price. And that's what's happening here, which makes it okay. All right? What we don't want is we don't want the same item to have two different prices. So imagine getting that Coke and then you ring it up at the register and the register gives you two different prices. Okay? That is when it's not a function. So if you look, all my items, all my X values only have one partner, one Y value. So this is a function. Okay? The domain is all your inputs or your X's. Okay, so I'm going to list all my X's. 3, 4, 5, and 6. 3, 4, 5, and 6. And I'm not going to put 4 twice because we're just listing them once. Your domain is all your outputs. If you look, all your Y's or outputs are the same, so we only really have one output, one price. And it's 2. Okay? That's how you do number 4. All right? For time's sake, we're going to skip 5 for now. I want you to check this out on the answers I gave you, the link. Okay, let's look at number 6. Again, we have item -1. What's the price of item -1? -$2. Okay, so -1 has one price. Any other -1s that have a different price? And the answer is no. -2 has a price of -$3. Do I have any other -2s items with a different price? Nope. -3 has a price of -$4. Any other -3s with a different price? No. And -4 has a price of -$5. So there is no other -4 with a different price. That means this is a function, and then our domain, we would list all our inputs, all our x values, which is the first number in our ordered pair. So -1, -2, -3, and -4. Okay. Our range is the outputs, the y values. So I'm going to list all the y values, -2, -3, -4, and -5. Okay. So this one, we actually are going over these type of problems in our next Zoom. So you haven't got there, but we'll talk about it now. What it says is, this is my function, okay? This is my input, okay? So right now, I don't know what I'm inputting, but I know that my output is -2. So if you look at your pairs up here, we're looking for an output of -2. And if you remember from the notes from last Zoom, this is your input, output, input, output, input, output, input, output. So what this is asking me to look for is, I want to know the input, because right now I don't know it. It's a variable, it's unknown. I want to know the input, so I want to find my x. X's are your inputs. I want to know my x if my y or my output is -2. So we're looking for an output of -2. Here it is. My output is -2, which means my x or my input had to be -1. So x should be -1. Okay? Again, we're going to go over problems like this in Zoom, so I'm going to start this for you. We're going to complete the following table. So think of this as your input, output. Okay? Input, output. So in essence, I'm going to take my first input and plug it into my B. So I'm going to input a 0 and then do the math. So it looks like this. Taking the function m, we are inputting 0. So wherever I see b, I put 0. And now we do and evaluate this, or do the math. Order of operations says 2 times 0 is 0. Bring down the 17. 0 minus 17, we get -17. So that means m of 0 is -17. Okay? So now we're going to do the next one. We would plug in m of 1. So let's plug in m of 1. So I'm going to use the same template here. So instead of 0, we are plugging in 1. And let's do the math. So when I plug in 1, that's what this says. There's really no math to be done here. It's just saying, hey, I'm using my function m, and I'm inputting 1. That's what this means. What do I get when I input 1? Well, we got to do the math. 2 times 1 is 2, minus 17. That gives me -15. Okay, so I'll let you fill in the rest. But I'm going to do 33 for you, just so we could get that done. All right, because we're going to use it later for one of the other answers. So let's plug in m of 33. Order of operations says 2 times 33 is 66. Bring down the -17. Okay, and now we just got to do 66 minus 17, and that gives me 49. So m of 33 is 49. All right, and it's very important that you understand the context. Basically, this equation is letting you know how much money Mr. Bean gets every time he sells burritos. So in other words, if he sells 0 burritos, he lost $17. If he sells 1 burrito, he lost $15. If he sells 33 burritos, he actually makes $49. Okay? And then the last one. What's great about functions is you can plug in other equations into it, other problems into it. So this last one really just looks like this. So let me show you what that looks like. So that's why functions can get really complex, because we can put in other problems inside of a function. All right, so it looks like this. We have m, function m, and we are plugging in not just a number, but a full-on expression. Okay, so again, there is no math to do here. We're just saying I'm using m and I'm plugging this guy in. Here's my input. What does it look like in the equation? It's 2, and instead of b, it's x plus 2 minus 17. Okay, and then we could clean this up as much as possible. We're going to distribute the 2. 2 times x is 2x. 2 times 2 is positive 4. And we bring down the 17. And then 2x plus 4 minus 17, we can combine these. Positive 4, negative 17, that gives me 2x minus 13. Okay, there's nothing more we can do. That's as simple as we can get. So when I plug in x plus 2 into my function, it actually turns into 2x minus 13. Okay? And that's it. That's basically showing that we can plug in other things besides just single numbers. All right? I'll let you finish that table. Okay, so give a reasonable domain and range for the function in the context of this problem. So remember, domain is, in this case, how many burritos is he selling? It's an input. Domain is always your input. So we want to give a reasonable domain. Remember, he is selling these burritos at lunch. So do you think that Mr. Bean would sell 1 million burritos during lunch? And the answer is probably not. So if you look at this table, it's showing that he possibly can sell 33. So I'm going to say maybe he can sell 50. So this is just, you have to kind of guess here what you think he can sell. So I'm going to use 50, or you can use the table. So his domain, he can sell anywhere from 0. He can't sell negative burritos. So he can sell from 0 burritos, I think around, we'll just use the table, all the way up to 33 burritos. Okay, this is one way of displaying your domain. So this is domain. Again, I explained this in our next Zoom, okay? So you're getting a little head start. That's one way of displaying domain. We also could display domain this way. So you have to know both ways. He can sell this many burritos, which means the same thing. And the way you read this is the burritos B he can sell can be greater than or equal to 0. So that means he could sell 0 or more than 0. That's what this statement means. But then there's a second statement. I don't think he can sell more than 33 according to the table. Okay, because according to the table, it stops at 33. So that statement says the burritos he sells are probably less than or equal to 33. So he can't go over 33 according to what I think. That's your domain. Now your range, same idea. Your range is your output. So based on what you see, how much is the money he can make? Remember, in this context, this is the money he's making. So we know that if he sells 0 burritos, he's making negative $17. So his range is, the least amount of money he can make is negative $17. And if he sells 33 burritos, What's the most money he can make? And that answer is $49. Okay, your range is your output, which we got from the table. So that's one way of displaying it. We're also going to put it in the other form, which is this form. So we're going to have, he could make negative $17 or more than that. But instead of putting B, like we have here, we're going to put our range variable, which is M of B. And we think he can make all the way up to, according to this table, $49. So he can make more than 17, that's what this statement says, but he cannot make more than 49, according to the table. Okay? So here, you're basically going to plug in -3, just like we did before. Okay, and kind of answer these questions. What does this number really mean? Remember, -3 is your input, and in this context, your input is the burritos. So can he sell -3 burritos? Can he sell half a burrito? Can he sell 20 burritos? Okay, so go ahead and plug that in. You'll see how much money he would make. But some of these answers don't make sense according to burritos he's making or selling. All right, part D. Describe what M of B equals 33 would mean for this problem. So we go to, on the table, M of B, and we look, and it says 33. So we want to know we say M of B equals 33. So what this means is, remember, this is your output, just kind of like I explained in this problem over here. They give us our output, but we need to find our input. So they give us our output. Okay, in this particular problem, our output is the money he made. Okay, what we need to figure out is the B, the input. And in this problem, the input is burritos. So I want to know, how many burritos did he have to make in order to get $33? And that's what this describes. Okay? So let's solve that out. So we're going to go and use our equation. We have M of B equals 2B minus 17. And if you look at what we have here, we know what M of B is. M of B is 33. So instead of M of B, I'm going to replace this whole thing with 33, because that's what it tells me to do. So this whole thing turns into 33, and now it turns into an equation we can solve. So this goes back to what we've been working on the last couple of weeks. So we're going to add 17 to both sides because we're solving for B. Okay. So that gives me 50 equals 2 times B. And how do I solve for B? I divide by 2. So how many burritos does he need to sell to make $33? He needs to sell 25 burritos. Okay, hopefully this helps.